Welcome to the future of software development, where coding is increasingly powered by artificial intelligence. In this video, we'll explore two cutting-edge concepts transforming how developers work: vibe coding and Anthropic Claude's Model Context Protocol, MCP. These AI-driven approaches are reshaping coding from a manual task into a higher-level design process. Get ready to see how AI can write code from just a description, and how new protocols let AI tools plug into live data for smarter, context-aware development. Vibe coding is a new way to write software without typing out all the code yourself. Instead, you describe what you want, and an AI model writes the code for you. The term vibe coding was coined by AI researcher Andrej Karpathy in early 2025. He demonstrated that by simply conversing with an AI, even using voice commands, he could build a working app without manually coding the components. In vibe coding, the developer's role shifts from writing syntax to guiding and refining the AI's output. You might say something like, create a web page with a sign-up form, and watch as the AI generates the HTML, CSS, and JavaScript for you. Karpathy described his experience humorously: I just see stuff, say stuff, run stuff, and copy-paste stuff, and it mostly works. In essence, coding feels more like having a conversation about functionality, rather than typing out every line. This approach makes programming more accessible. Even someone with minimal coding skills can produce software by coding in English, instead of in a traditional programming language. However, vibe coding isn't magic. It works best for relatively straightforward tasks or prototypes. As Karpathy noted, AI can still get stuck on bugs or misunderstandings, so the human needs to nudge it in the right direction, or make adjustments when the AI code isn't perfect. Overall, vibe coding represents a paradigm shift. You focus on what the program should do, and the AI figures out how to do it in code. Vibe coding went from concept to reality thanks to a new generation of AI-powered developer tools. Let's look at some of the most popular ones enabling this shift. OpenAI ChatGPT and Anthropic Claude. These AI chatbots can generate entire code snippets or even full programs from plain English prompts. Developers use ChatGPT or Claude in a chat interface to request features or ask coding questions, and the AI returns code that can be copied into a project. For example, you can prompt "write a Python function to sort a list of orders by date," and the AI will output a well-structured function on the spot. These tools excel at explaining code and debugging too. You can paste an error message and get suggestions for a fix. They essentially act like on-demand pair programmers available 24/7. GitHub Copilot. Copilot is like an AI pair programmer living inside your code editor. It integrates with VS Code, Visual Studio, and other IDEs to suggest code as you type. If you write a comment saying / decrease the padding of sidebar by 50%, Copilot will instantly generate the code to do that. It's trained on billions of lines of open-source code, so it often knows exactly what boilerplate or API call you need. Copilot can complete whole lines or functions automatically, which means you spend less time typing repetitive code and more time confirming the AI's suggestions. Microsoft and OpenAI are even adding Copilot chat and voice features, so you can literally talk to your editor and have it implement changes. This tool highlights how AI can handle the mundane parts of coding, letting you focus on the high-level design and logic. Replit Ghostwriter. Replit's Ghostwriter takes vibe coding to the cloud. Replit is an online IDE, and with Ghostwriter AI, you can describe an entire app, and the platform will build it in your browser. Imagine opening Replit and saying, create a Node.js web server with a homepage and a login form, and Ghostwriter scaffolds the project for you. HTML, CSS, backend code, all generated instantly. It can even deploy the app for you. Ghostwriter assists with code completion and can generate entire files or explain code on command. This means a solo founder or a hobbyist can go from idea to a running prototype without wrestling with setup or configuration. By handling all the boilerplate setup, Ghostwriter empowers developers to iterate rapidly. It even supports collaborative mode think pair programming, but one of the pair is an AI. Cursor, AI code editor. Cursor is a new IDE built from the ground up for AI-assisted coding. It has a chat sidebar where you can issue instructions like, optimize this function, or add a user login route, and the AI will directly modify your codebase accordingly. Cursor's strength is project-wide context. It can understand your entire code repository, not just the single file you're editing. This means it can do things like find all references of a function, perform multi-file refactors, or incorporate context from other modules when generating code. It's like having an AI that truly reads your whole project. In fact, Cursor even supports Claude's Model Context Protocol, which we'll discuss soon, allowing it to pull in external knowledge such as API documentation to assist in coding. In practice, developers using Cursor can stay in a flow state. Whenever they get stuck or need a chunk of code written, they just ask the AI within the editor, and it appears. All of these tools share a common theme. They eliminate the drudge work of programming. Tasks like writing boilerplate code, setting up frameworks, or searching Stack Overflow for syntax can be offloaded to AI. The developer is freed to focus on creativity, architecture, and solving the core problems. In a vibe coding workflow, you spend more time deciding what to build and letting the AI figure out how to build it. This collaboration between developer and AI leads to faster development cycles and a more intuitive way to create software. How is vibe coding used in practice? Let's explore a few real-world scenarios and workflows where AI-assisted coding shines. Indie game development. Imagine a solo game developer at a game jam with only 48 hours to create a game. Using vibe coding, they can describe game mechanics, and the AI produces working code for character movement, physics, or UI elements. For example, they might say, make the player character jump twice as high and add a blue particle effect, and the AI inserts the code changes. This enables rapid prototyping of ideas that would normally require a team. One person can accomplish in days what might otherwise take weeks. The iterative nature of vibe coding is perfect for game jams. The developer can continually refine the gameplay by conversing with the AI without getting bogged down in syntax errors. The result is more time spent on creative tweaks and less on debugging boilerplate. Startup MVPs and SaaS projects. A small startup or a solo entrepreneur can leverage vibe coding to build a minimum viable product extremely quickly. Suppose a founder wants to launch a web app for a new SaaS idea but has limited coding experience. They can use a tool like Replit Ghostwriter or ChatGPT to generate the back-end APIs, database schema, and front-end components by simply describing what the app should do. User sign-up, data visualization, etc. We've seen examples of developers saying, I vibe coded this app, meaning they built full prototypes by letting the AI handle the bulk of coding. In fact, an experienced iOS developer reportedly vibe coded a complete app in just 3 hours. Another product manager with no coding background used AI to draft an app's code. While they eventually had to get hands-on to polish and fix issues, the AI jump-started the project significantly. This demonstrates how vibe coding can empower people to bring ideas to life with minimal engineering effort. Startups can test ideas faster and cheaper, reducing the barrier to entry for launching new software. Solo developers and hackathons. Even outside of startups, regular developers are incorporating vibe coding into their daily workflow. A solo dev working on a side project can use AI to handle tedious tasks like setting up authentication or converting one data format to another, freeing them to focus on the unique parts of their project. In hackathons or hack days at companies, teams that use vibe coding tools can produce more complete demos by the deadline. For example, a hackathon team might plug an AI assistant into their IDE to rapidly generate code for the boring parts, database connectors, REST API endpoints, allowing the team to focus on the innovative feature that sets their project apart. The workflow often becomes describe, generate, test, repeat, a very fast iterative loop. This can lead to a more experimental and playful style of programming, where you try out ideas by asking the AI to implement them, and if it doesn't work, you quickly ask for changes or revert. Developers have shared anecdotes of building whole features while hardly touching the keyboard. They simply supervised the AI and guided it when needed. In each of these cases, vibe coding serves as a force multiplier. It accelerates development and expands what an individual can achieve. However, these workflows also highlight that human guidance is still critical. The AI might generate 90% of the code, but the developer must test it, tweak it, and ensure it meets the goal. The synergy of human creativity and AI speed is what makes these use cases so powerful. Vibe coding offers tremendous benefits, but it also comes with some trade-offs that developers need to consider. Let's break down the pros and cons. Benefits: speed and productivity. AI-assisted coding can significantly accelerate development. Routine tasks that might take hours can be done in seconds. This means faster prototyping and shorter time to market. One engineer noted that an AI can generate code an order of magnitude faster than a human for many tasks. With vibe coding, you can quickly iterate on ideas. If you can describe a feature, you can have a first draft of it almost immediately. This speed also lets teams be more agile and responsive to feedback. accessibility and democratization. Vibe coding lowers the barrier to entry for programming. People who aren't traditional software engineers, say a business analyst with an idea or a hobbyist, can create functional software by describing what they need. It opens the door for more people to automate tasks or build apps without extensive coding education. In an industry where demand for developers often outstrips supply, having AI bridge the gap is invaluable. It's like having a supercharged junior developer who can work with you, enabling even small teams or solo makers to build things that used to require larger teams. Focus on higher-level design. Because the AI handles boilerplate and syntax, developers can spend more time on creative problem-solving and design. You can concentrate on the big picture, the user experience, the system architecture, the core logic, while the AI takes care of the nitty-gritty details. This can lead to more innovative solutions because you're not getting bogged down in setup or syntax. Many developers find vibe coding to be a more enjoyable experience overall, since you're collaborating with the AI and seeing results quickly, rather than wrestling with trivial bugs or configuration. Drawbacks. Lack of deep understanding. When you let the AI write a lot of your code, you might not fully understand the codebase it produces. This can be dangerous. If a bug or security issue arises, a developer needs to comprehend the solution. Critics of vibe coding point out that blindly accepting AI-generated code can introduce unknowns into your software. If you didn't write it, you might miss subtle mistakes. There's a risk of becoming too dependent on the AI and losing some traditional coding skills or insights. Bugs and inaccuracies. Today's AI models, while powerful, are not infallible. They can produce code that doesn't work or is inefficient, or they might misunderstand your intent, and they often do so with great confidence. If a developer assumes the AI's output is 100% correct, they could end up with broken features or hidden bugs. Testing and review are still absolutely necessary. In vibe coding, a lot of debugging might shift to a cycle of prompting the AI to fix its own mistakes, which can be quick, but sometimes the AI gets stuck or goes in circles on a problem it doesn't understand. Security and reliability concerns. AI-generated code can inadvertently introduce security vulnerabilities. For instance, it might use a library in an insecure way or generate code susceptible to injection attacks if the developer doesn't specify security requirements. Also, because the AI doesn't truly understand the code's intent, it might not handle edge cases or performance considerations well. Pushing AI-written code to production without careful review is risky. You could expose your system to exploits or crashes. Companies adopting vibe coding need to implement extra code reviews or use AI code analysis tools to double-check for vulnerabilities. Maintainability and team communication. Codebases created largely by AI might be more difficult for humans to maintain in the long run, especially if the original prompter isn't around. The AI might use an unconventional structure or overly complex approach that a human wouldn't, making it hard for other developers to pick up later. Additionally, there's a cultural aspect. In a team setting, if one developer vibe codes a feature, others need to read and understand that AI-authored code. Ensuring clear documentation and readability can be a challenge. You may have to prompt the AI to explain or document the code as an extra step. In summary, vibe coding is a powerful tool. It can make coding faster and more accessible, but developers must use it responsibly. That means staying in the loop, testing the code, understanding what you deploy, and treating the AI as an assistant, not an all-knowing oracle. Many experts suggest that vibe coding is best for prototypes, internal tools, or early-stage development. For critical production code, the AI's output should be rigorously reviewed and perhaps rewritten to meet the project's standards. By balancing the benefits against the drawbacks, developers can harness vibe coding effectively without undermining software quality. Now let's switch gears to our second major topic, Claude's Model Context Protocol, or MCP. If vibe coding is about how AI can help write code, MCP is about what your AI assistant can see and do beyond the code. It's essentially an open protocol that lets AI models connect to external data sources and tools. Think of MCP as a kind of USB-C for AI, a universal connector that allows any AI to plug into any data source in a standard way. Just like USB-C replaced a bunch of custom cables with one common port, MCP aims to replace ad hoc integrations with a single, consistent interface for connecting AI to the outside world. Traditionally, AI assistants like ChatGPT or even Claude without MCP operate in a silo. They only know the information in their training data, and whatever you provide in the prompt. They can't fetch a file from your computer, call an API or query a database on their own. If you needed them to have some external info, you had to copy-paste it into the prompt or build a custom plugin. MCP changes that. It provides a standardized way for AI to reach out and get live data or perform actions securely and with permission. For example, with MCP, Claude could retrieve a document from your company's Google Drive, or get the latest entries from a database, or even send a command to a cloud service, all through a well-defined protocol. Anthropic, the creators of Claude, introduced MCP in late 2024, open sourcing it to encourage industry adoption. It's designed to work not just with Claude, but with any AI system that implements the protocol. The core idea is context extension, giving AI access to fresh, relevant context whenever it needs it. Instead of being limited to its built-in knowledge, an AI can say, I have a tool I can use to get more info, and then use MCP to fetch that info. This could be as simple as reading a local file or as complex as querying an enterprise content management system. Importantly, MCP is built with security and privacy in mind. It's a two-way, consent-based connection. Developers set up MCP servers, little connectors that know how to talk to a certain data source, and those servers only provide the data or actions they're configured to expose. The AI, acting as an MCP client, can only access what the server makes available, nothing more. And all of this happens with the user's authorization. Think of an MCP server as a gateway to something like your code repository or Slack chat. The AI can ask that gateway for specific things, for example, give me the file utils.py from the repo, or search the Slack channel for error messages, and the server will hand over the info if allowed. But it won't hand over everything, and it won't let the AI do random, unapproved operations. This ensures that connecting AI to powerful tools doesn't turn into a security nightmare. By standardizing how AI connects to external systems, MCP opens up a world of possibilities. Early adopters have already started integrating MCP. For instance, the developer tools Zed, Replit, Ghostwriter, and SourceGraph are working with MCP to let AI assistants fetch relevant code from projects and documentation, so the AI can produce more accurate and functional code with fewer attempts. Companies like Block, formerly Square, and Apollo are using MCP to link AI agents with their internal systems, envisioning more agentic AI that can actually act on the user's behalf within bounded systems. The endgame is AI that isn't stuck in a chat box. Instead, it's embedded in your environment, aware of context and able to help with real tasks using real data. MCP is a key step toward that future, establishing the common language and safety guardrails for this kind of AI capability. So how does MCP actually work under the hood? Let's break it down without getting too bogged down in technical jargon. MCP follows a client-server architecture built on a protocol called JSON-RPC, which is a lightweight format for remote procedure calls using JSON. When you're using Claude with MCP, via Claude's desktop app or an IDE extension, Claude acts as a host that can manage multiple MCP client connections. Each client connects to one MCP server, and each server is a small program that knows how to interact with a specific data source or tool. So, you might have one MCP server for your local file system, another for a database, another for an external API. Claude can launch or talk to all these servers in parallel through the standardized MCP interface. The communication is two-way and session-based. That means when Claude connects to an MCP server, they establish a session and start talking JSON messages back and forth. For instance, the AI might send a JSON request saying, get me the content of file utils.py, and the server will respond with the file data. Because it's JSON, everything is structured, like method read _ file, params path utils.py as a request, and then a response with either the text or an error code. JSON-RPC is nice because it's language agnostic and easy for developers to implement, and it supports sending responses asynchronously. In simpler terms, the AI can call functions on the server as if it's an API, and the server returns results in a format the AI understands. The host, Claude's runtime, orchestrates all this. It's what spawns clients and connects to servers. The host is also the gatekeeper. It ensures each client-server pair is isolated for security. Isolation is crucial. An MCP server for files only sees file-related requests and nothing else. If you also had an MCP server for Slack messages, that Slack server can't eavesdrop on file contents because the host keeps their contexts separate. The AI, Claude, is the only entity that has the full picture, and it decides what to do with the information from each server. This design prevents a tool from overreaching. It only does what it's asked to, and only sees what it's authorized to access.